Okay, let us start. So, uh, just click on that presentation mode. Okay, ठीक है? Like that second particular. I'm sharing my screen now. That one. In the okay means it's visible now perfectly in like. Uh, okay, okay. No, no means like the laws of motion is in perfect that way only now. That's what I want. Yes, yes, that's what I wanted. Okay, so we are going to deal with this particular chapter, which we call it as laws of motion. I don't know why they are calling in laws or something like of motion, but something we are going to study about motion, isn't it? कुछ ना कुछ तो पढ़ेंगे ही मतलब कुछ ना कुछ करनामा करेंगे ठीक है so I call it as in-laws of motion because we have came across kinematics, then we move to this chapter. Okay, so in-laws, just father-in-law, sister-in-law, and all those kind of in-laws and all. So that's what kind of in-laws of motion. Okay, so like because I'll tell you why I call it as in-laws of motion. So like in motion, in kinematics, we study how the motion happens. Okay, but then there are our sasumas and all who asked na why you did like that, why you did that, when you did that, what's the reason for that. So that's why this chapter, yeah, so that's what is this chapter, judgment of kinematics. Okay. Okay, so yeah, so it's this chapter is also going to judge our chapter motion, how the motion happens, कैसे किया तूने बेटा, कौन सा फोर्स किधर लगाया, ये सारी चीजें ये तो चैप्टर ही बताएगा. That's why we call it as in laws of motion, sister in law of motion. Are you able to get me or not? ठीक है, so we'll start this. We'll start with some basic concepts, then we'll move ahead to the depth of it. The depth of it will start by tomorrow, but today we'll develop the basic nature, basic concepts, why motion, what are the typical things in motion, and then as usual we'll move ahead. Okay, okay, so be ready. Okay, so see this now. Basically to talk about motion, so if I want to talk, I'll just pick up something, then I'll go to those ppts and all. So if I want to talk about motion, what comes in your mind? Okay, means movement, isn't it? The word that will appear is first thing is movement. Then this movement happens with respect to something, and that we call it as time. Movement can also happen with respect to particular, लेट सपोज मतलब मान लो एक ऐसा रोड है, ठीक है, ऐसा रोड दे दिया गया, ठीक है, और यहाँ पे ऐसे एक कार चल रही है, मान लो एक कार है, ठीक, वैसे कार एक किसी रफ्तार के साथ मूव कर रही है. तो अब ये जो कार की मेजरमेंट है वो दो तरीके से हो सकती है. या तो मान लो मतलब एक पे एक मैंने एक ऐसा प्लांट मान लिया, ऐसा लगा हुआ है, ठीक, और इस प्लांट में कोई एक मंकी बैठा हुआ है, ठीक, तो ये मंकी इस टेलीस्कोप लगा के ऐसे कार को देख रहा है, अरे ये जो कार है उसके अंदर सुंदर कन्या बैठ के, कैटरीना कैफ बैठ के जा रही है ना. या फिर एक यहाँ पे ऐसे मान लो एक ऐसे यहाँ पे मान लो एक चाय चाय टपरी का दुकान है, चाय की टपरी है, ठीक, वहां से एक पर्सन खड़ा होकर देख रहा है, वो भी तो देख सकता है ना. जब दोनों देखेंगे तो कुछ ना कुछ तो डिफरेंस नजर आएगा ही आएगा. आर यू एबल टू गेट मी और नॉट? So basically the motion, this velocity also depends upon these two persons also or not. Means observer dependent. This is observer dependent, isn't it? Okay. So when we define our motion with respect to some observer, these observers are often taken by a name as frame of references. Like why I call it as frame of references, because on these objects I can draw a three-dimensional coordinate system, and with respect to that I can definitely plot this velocity in this three-dimensional coordinate system or not. Yes. So, and for similarly for this observer, I can also draw the three-dimensional coordinate system, and I can even talk about the velocity in that particular frame. So that is why these frames, which are talking about the motion of the particles which are kept in this frame, and since they are the basis of measurement or observation, they are called by a name called as frame of references. क्या बोलते हैं इसे? Are you able to get me? Now, when we will come across, we will see there are two kinds of frame of references. One is inertial, Another one is non-inertial. So I'll talk about this inertial and non-inertial in depth in this chapter. Are you able to get me or not? Yeah, means no, but those were just the formulas. But the real definition of inertial and non-inertial, what actually happens, their basic formulas, how to write the inertial concept, how to write the non-inertial concept through a derivation, will move ahead. Are you able to get me or not? ठीक है, मतलब हम पूरे डेप्थ में जाएंगे, मतलब ऐसे तुम्हें प्रो बनाऊंगा इस चैप्टर में। आर यू एबल टू गेट मी? ठीक है। And even you can, like, these all the videos are recorded and they are getting to be uploaded on YouTube, so you can even follow on YouTube and see all these things, okay? चलो, तो अब किसी भी, मतलब अब एक एक क्वेश्चन एक दिमाग में आता है, मतलब ऐसे सोचता है इंसान कि अगर हम इस, मान लो एक ऐसे एक रोड मान लिया और इस रोड पे एक ब्लॉक रख दिया है ना, ठीक है। दो ब्लॉक्स रखे हुए हैं, ठीक, there are two blocks. Since I'm making you from a scratch, try to understand. Their masses are m1 and m2 given over there, isn't it? Or a person is applying a force, a same amount of force on these two blocks. Right or not? It is said that m2 is greater than m1. तो एक बात बताओ, बेसिकली अगर इस पर्सन को मूव कराना होगा, मान लो मैं ही ऐसे खड़ा होके ऐसे धक्का मारने की कोशिश कर रहा हूँ, तो जब मैं धक्का मारूंगा इन दोनों ब्लॉक्स में से, तो कौन सी ब्लॉक इजीली मूव कर जाएगी, m1 या m2? m1 can easily move while it will be very hard to move m2, isn't it? Why? Because the m1 is lighter than m2, ऐसा बोल सकते हैं, है कि नहीं? अच्छा, अब ये कॉन्सेप्ट तो मतलब हेवियर और लाइटर तो ठीक है, बट तुम्हें मूव कराने के लिए क्या ये ब्लॉक अपने आप मूव कर गया? नहीं। टू मूव इट यू नीड टू अप्लाई सम फोर्स और नॉट? यस। And as you will remove this force, the mass m1 will once again come to rest, isn't it? If this surface is rough, are you able to get me or not? But if this surface is not rough, if you even remove this force, these masses will still go on motion, मोशन में चलते रहेंगे। तो ये जो कॉन्सेप्ट है कि फोर्स लगाने पे क्या हो रहा है, फोर्स हटाने पे क्या हो रहा है, बॉडी एज इट इज रह जा रहा है, बॉडी कुछ कर नहीं पा रहा है, कुछ बिहेव नहीं कर पा रहा है, तो दिस पर्टिकुलर द एसेंस, इस पर्टिकुलर एसेंस का ही नाम पड़ता है इनर्शिया। इस एसेंस का नाम क्या है? So the first word which we will learn in NLM is called as the word inertia, and then we'll move to the other topic of the NLM. Are you able to get me or not? So let us talk in detail what is this inertia called as, and then with the help of inertia we will define our what is going to be the definition of mass based upon inertia. Will give that. Okay, is that clear? So let us start this and let us see what is called as inertia. So this is a person who is trying to move this sofa. Okay. So a man in the picture is trying to move a sofa, but the sofa is not willing to move. Sofa is trying very hard that, oh, I should not move it. Are you able to? I should not move. Are you able to get me or not? So basically, the point is what means if there is a sofa in any kind of object, if I keep it on a surface, means all those objects will never ever try to move by own, isn't it? So that's what it is written. No object in this world starts moving on its own. कोई भी ऑब्जेक्ट दुनिया में अपने आप से मूव करने की कोशिश ही नहीं करती है। मीन्स हो क्या है, या तो बॉडी पूरी तरह से लेजी है, मतलब जैसे हम सुबह सुबह उठने की कोशिश नहीं करते हैं ना, मतलब मान लो अगर हम ठंडी की मौसम है और सोए हुए हैं तो सुबह उठने का मन करता है क्या? हम्म, नहीं। So basically the things over here are also behaving like they are lazy and they didn't want to move. But then the question arises that how does the movement happen? Are you able to get me or not? ये movement हो कैसे रहा है? So we can also say that since sofa is too much big, we can't move it. Something like that. We can have an assumption like, okay, this is so heavy, I can't move it. This is so easier to move. So all these movement are appearing for one of these kind of conditions, heavy, lighter, something like that. It is appearing or not? Yes. So they, that is going to be given, or that is going to be brought to some more conclusion. It is saying that the sofa is trying to behave as it is. Even if you are applying the force, it is still stable. Means All any kind of thing, whichever thing is there in the universe, all are behaving like nothing is happening to them until and unless you apply the force. Are you able to get me or not? So they are behaving like a lazy guy or not? Yes. So that means what? The whichever thing is there in the universe, they like to stay as it is. अगर मान लो ऐसे अगर मान लो एक ऐसा रोड पे ऐसे मतलब ऐसे ऐसे एक रोड पे ऐसे ट्री अगर मैंने खड़ा कर दिया तो ट्री ट्राई करेगा कि बेटा तुम मेरे को जड़ से उखाड़ो नहीं, है ना? ऐसा 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 सोचने की कोशिश करेगा या नहीं करेगा? So anything in the universe, whether it is non-living or living, they always try to be as it is as they were initially. Are you able to get me or not? And this as it is, as they are, the word as they are is called as or known by the word inertia. So inertia is not a physical quantity. We can't say that inertia is a physical quantity. Are you able to get me or not? It's just a word. Okay, not a physical quantity. It's just a what? Word. It's just a word which says that let me be as it is. I didn't want to do I didn't want to do anything. Let's suppose if a person is laughing, then he will say, if I say, hey, you are inertia of laughing, then what he will do? He will always laugh. If a person is sleeping, if I say inertia of sleeping, he will always sleep. Are you able to get me or not? So that is why we call means this particular inertia is nothing but a word which says let it be as it is, there should be no change. Are you able to get me or not? And that is what is brought us to conclusion that things want to stay in the same position as they are, things want to keep doing what they are already doing. How come things, how can we can say things are lazy? So that is what we bring to condition that the name of this laziness, physicists have a special name of this laziness, and this laziness is called by a name inertia. Are you able to get me or not? So what is inertia? Inertia means laziness. Inertia means what? Laziness, nothing else. Are you able to get me or not? There is nothing like in this world which will bring us to anything. So it means you can also say that inertia is nothing. The word a common understanding of laziness is do not do not change. Basically, do not change me, sir. Not willing to change. Are you able to get me or not? Laziness means only that thing only. But laziness brings the smartness, isn't it? A lazy guy will find a better shortcut to do work, and that is why inertia brings us a better shortcut to understand motion. Are you able to get me or not? So that is why we will connect it and we will see how it happens. So if things are at rest, they want to stay in rest. That is what is the meaning of inertia. If things are in motion, they want to move in on motion, and this is called as Newton's first law. Are you able to get me or not? So Newton's first law is nothing, but it is, you can say it is a law of inertia also. It is called as law of inertia because it says that whenever any kind of body is there, you will always remain in a state of rest or a state of motion until and unless external force is applied. Are you able to get me or not? Yes. So what do you got to know? Many people still think that inertia is a physical quantity. You know that, but it is not a physical quantity. Remember that. It's just it's just a word, a Greek word which tells do not change. If I say inertia of laughing, you will always laugh. If I say inertia of sleeping, you will always sleep. If I say inertia of loose motion, you are always going to do loose motion. Are you able to get me? So that's what is called as inertia. Is this clear? Yes. And then the word, this the description of this word is given by law of for Newton's first law. So you can also say that Newton's first law, our Newton's first law is nothing but a talk or a description or a description of word force. ठीक है? Are you able to get me or not? Basically, what is it talks only about external agency. First law even do not give the word force. Are you able to get me or not? It's just telling that you need to bring some external agency to change the inertia of the system. Means you can also combine. inertia as initial condition. Okay, whatever is the whatever is the initial condition of the body, if I want to change it, I need to change my inertia also. Are you able to get me or not? To change these initial conditions or to change these things, you need an external agency. मेरी बात समझ में आई या नहीं आई? Is this clear or not? मजा आया? Can I move ahead? So, what is inertia? Can you just tell me? बताओ. It's A only. Simple. That of course B and C are also possible, but there is a combined thing. Okay, that it can also prevent from motion. It can also prevent from rest. Inertia always opposes the change in any of the state, either the rest, either the motion. You can, in common sense, you can say it will always resist the change in initial condition. Inertia means, in common terms, resistance. Take a resistance to change in initial conditions. Okay, can I move ahead? Okay, so basically now we come across what are the different kinds of inertia. We'll see that and we'll talk about that. So basically, the first type of inertia is called as inertia of motion. We are not going to talk about rest first. We are going to talk about motion first. That it says means once again inertia means what? Resistance to change. So basically do not change motion. Can I say right? Can I write like this way? Inertia means do not change. So do not change of motion. Are you able to get me or not? Means that if a body is moving with some kind of velocity, inertia will change. Do not change this velocity. If a body is moving, remember that if even if I say that this is my road, okay, and this is my block of mass m1 which is moving with velocity v1, and this is my block of mass m2 which is moving with velocity how much? v2. Then there is a change over here or not, whether v2 can be greater or less than v1. But whatsoever happens, ये velocity basically change हो गई या नहीं हो गई? चेंज हो गई. तो जैसे ही तुम्हारी velocity चेंज हो जा रही है, इस चीज को हम बोलेंगे, इस चीज को ही वो रेजिस्ट करेगा inertia. Are you able to get me or not? Even this velocity changes, if you want to bring, you need to bring one external agency, then only these particular velocity changes are also possible. Are you able to get me or not? So it does not mean that if I'm in motion I'll always come to rest. It's not like that. Motion means condition of one motion to another motion. Okay, it will resist all those changes. Even it will resist to change in V2, it will even resist to change to 0, even it will even resist to minus V1. Are able to get me or not? All these changes are going to be resisted, and provided this resistance is called as inertia of motion. Are you able to get me? Oh, set here it is written. Okay, so here just change it. In the inability of the body to change its state of motion is called as inertia, unless and unless external force acts over here. Are you able to get me or not? ये बात समझ में आ रही है? मतलब ये जो बॉडी अगर इस किसी वेलोसिटी से जाएगा, हर तक इसी वेलोसिटी को फॉलो करते रहेगा. ठीक है, मैं आगे बढ़ूं. अब ध्यान से देखना that now the particular next is inertia of rest. What does it says? The body at rest will always remain at rest. Let's suppose if a body is kept over here of mass m, it will always remain at rest. There will be no velocity until and unless if you apply some external force over here. Are you able to get me or not? So this particular property to always remain in rest, to not change rest, is called as inertia of rest. Are you able to get me or not? Yes. अब ध्यान से देखो. Next, the third one is the most important one, which people do not take it in things, and that is inertia of direction. Try to see if there is a straight path first, and then there with the attached there is a curvical path. ठीक है. अब मान लो इस पे कोई कार जा रही है ना. ठीक, एक पर्सन ड्राइव कर रहा है इसको, है ना. एक पर्सन ड्राइव कर, तो तुम सोचो जैसे ही कार यहाँ पे आएगी, वो ड्राइवर क्या करेगा, कुछ ना कुछ तो उसको प्रोवाइडेड एक फोर्स लगाना पड़ेगा ना उस पर्टिकुलर स्टीयरिंग के थ्रू, ताकि ये पर्टिकुलर बॉडी अपनी डायरेक्शन को चेंज कर पाए इस तरफ, है कि नहीं. यस. तो ध्यान से देखो, इवन इफ यू वांट टू चेंज द डायरेक्शन ऑफ द बॉडी, you need to apply some external force, and that is why we brought the condition that yes, for the force I can also bring the inertia of direction, that do not change the direction. If you want to change the direction, apply the force. Got it or not? Otherwise get the hell lost of here. Are you able to get me? मेरी बात समझ में आई या नहीं है? तो how many types of inertia are there? Three. Inertia of rest, inertia of motion, and inertia of direction. All of these always talk about do not change these conditions. Are you able to get me or not? Yeah. So this is why it is called as the inability of the body to change its own direction by its own until unless an external force acts on it. Are you able to get me or not? मेरी बातें समझ में आ रही है नहीं आ रही? Is this perfectly clear? Yes. So then, with the help of inertia, we'll bring the conclusion of one of the most important definitions of physics, and we call it as mass, isn't it? If I define inertia, then I could define mass, isn't it? So tell me, what is mass? Measurement of? पता नहीं. सोचो. is, is it like that? Uh-huh. Is it that particular thing? Tell me, what can be mass? Uh-huh. I do not know. Like, I tried that YouTube stream, live stream, but it's not happening. Let me just take that thing. Physics. You know how many subscribers I have? 7,000. ठीक है. अच्छा, 1 minute. Just let me message myself that stream is not getting possible. ठीक है. अब ध्यान से देखो. चलो. तो mass, basically, if I want to talk about mass, many people will say mass is nothing but the amount of matter. They will say like that, isn't it? That's that's the chemistry definition. Now, if I look into the two objects, like there were two objects, mass m1 and m2. एक m1 हो गया और दूसरा क्या हो गया, m2, है ना. अब ध्यान से देखता हूँ, तो अगर दोनों पे जब मैंने सेम अमाउंट ऑफ फोर्स लगाया, तो हमें मालूम चलता है कि द बॉडी of the this particular body can move easily, and this body is moving in a hard way. Yes. So in simple terms, can I say that this has more inertia, but this has less inertia? Now, if you look into these inertias, these more inertia and less inertia are only compared when the body is moving in a linear path or not. So the less inertia and more inertia, the word less inertia or more inertia, even it is appearing for these kind of bodies, and that's why we define mass as nothing but the measurement of which kind of inertia? Translational inertia. Basically, this heavier inertia, less inertia, more inertia in the particular straight path, if I want to understand, so then we coin this, since inertia is not a physical word, not a physical quantity. So we bring the physical quantity to measure this inertia, and that is defined as mass. Are you able to get me or not? So measure mass is nothing but the measurement of which kind of inertia? Translational means linear changing inertia. Are you able to get me or not? Linear path inertia. Are you able to get me? Is this clear? And then that's why we take है that's why we bring this concept of mass over here. Is that clear or not? ठीक. अब चलो अब आगे बढ़ते हैं. अब मास तो मूव करने लगा. अगर मास मूव किया तो इसके पास कुछ ना कुछ तो रफ्तार होगी ना. यस, कुछ ना कुछ तो रफ्तार होगी. अब एक एग्जांपल लेते हैं. अब एक चीज सोचते हैं. ठीक है. मान लो एक 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 ग्राउंड पे एक मतलब एक ग्राउंड पे है ना. एक ग्राउंड पे दो मासेस को मैं गिराता हूँ. दो स्टोन्स गिराता हूँ. एक की मास m1 है, दूसरे की मास कितनी है? m2. ठीक है. एक की मास कितनी है? m1, दूसरे की मास कितनी है? m2. ठीक है. और दोनों किस हाइट पे प्रेजेंट है? सेम हाइट पे प्रेजेंट है. दे आर प्रेजेंट एट सेम हाइट. ठीक है. अब मान लो मैं इन दोनों के नीचे श्रुति को खड़ा कर दिया. मैंने बोला श्रुति बेटा तुम, हाँ सॉरी, सृष्टि को खड़ा कर दिया. अब बताओ, अगर दोनों मासेस गिरेगा तो इसमें चांसेस सर फूटने का सबसे ज्यादा किस में रहेगा? मास टू. लेकिन एक बात बताओ, हमें तो मालूम है कि अगर सर डिस्प्लेसमेंट h है तो इस पॉइंट पे जो वेलोसिटी आएगी दोनों के लिए सेम होती है, विच इज रूट अंडर 2gh. Yes, these velocities are independent of mass. Then why the hell? Then why the hell? In the second case, the person will have a greater damage, isn't it? बताओ क्यों ऐसा हो रहा है? Because the mass is more. How come the mass is okay? So mass is more. That's why something like that is appearing. Yes, some mass is there of the second stone, which is more than m1, and when it is hitting the person, suddenly that mass is appearing over there. Although their velocities are same, isn't it? So this particular terminology, see, if I just take another case, if I just take the same person and drop these two masses from a less height, then the probability of again getting destructed is decreasing or not. मतलब अगर मान लो इसी इसी पर्सन के ऊपर दोनों मासेस को थोड़े कम हाइट से ड्रॉप किया, तो क्या मालूम चला कि सर दोनों अभी इफेक्ट नहीं कर रहा है कि नहीं. तो सिर्फ और सिर्फ मास ही रिस्पॉन्सिबल नहीं है, साथ में वेलोसिटी भी रिस्पॉन्सिबल है ना उस ग्रेटर डैमेज के लिए. एंड दैट, see, I'm saying simple thing. I'm just taking you through the logical case that let us see that on this person, if both of the stones are dropped from a less height, okay. So in both the scenario, in this scenario, the velocity after dropping will be very very less or not. Yes, and if the velocity got decreased, the chances of breaking of his skull has been once again decreased or not. Yes. So what do we got to know? That mass is responsible. These masses which you said, sir, if height h are there, then m2 will be having more effect. M2 will be having more effect than M1. And similarly, if I consider the second case over here, let's suppose this is my velocity V2 and V2. So V2 will have more effect than V1, isn't it? V1 is, let's suppose, some initial case. Are you able to get me or not? So what do we got to know? That it's not only the mass which is responsible for damage, it is the velocity even. अच्छा समझ में आया कि नहीं ये बात की मतलब अगर हम डैमेज के बारे में बात करने की कोशिश कर रहे हैं तो सिर्फ मास ही रिस्पॉन्सिबल नहीं है, साथ में उसका क्या रिस्पॉन्सिबल है, वेलोसिटी भी रिस्पॉन्सिबल है। अगर ज्यादा वेलोसिटी है तो ज्यादा डिस्ट्रक्शन हो रहा है, कम वेलोसिटी है तो कम डिस्ट्रक्शन हो रहा है। ठीक, अगर मान लो कि एंट को लाइट के स्पीड से चला दिया तो उससे कम डिस्ट्रक्शन होगा, लेकिन अगर वहीं पे एक हाथी को लाइट लाइट के स्पीड से चला दे रहा हूँ तो वहां पे ज्यादा डिस्ट्रक्शन हो रहा है। आर यू एबल टू गेट मी और नॉट? So this particular concept of mass and velocity which are appearing at the same time, and we call this particular term as momentum. क्या बोला इसे अपन ने? क्या बोला? Momentum. Are you able to get me or not? So basically look into the scenario. अब मतलब समझो जरा कि है क्या चीज ये मोमेंटम। तो देखो यही बोल रहा है कि when two stones are of different masses are dropped from the same height on the vehicle, which one will cause a greater damage? The stone with the larger mass dropped from the greater height causes greater damage, since its product time mass and velocity is what? Large. So that's what is appearing, the product. Why this product is appearing then, isn't it? Even I can consider mass by velocity. But then the things will change. Here, the damage is even directly proportional to mass, and even the damage is directly proportional to my velocity or not. So that is why damage is told that it is directly proportional to mass times velocity. Are you able to get me out? Is this clear or not? And this is why this product is going to be called as moment. क्या बोले इसे अपन? मोमेंटम। अब क्वेश्चन आता है कि सर इसका नाम मोमेंटम क्यों पड़ा? तो क्या तुम बोल सकते हो कि मोमेंटम इज नथिंग? मान लो एक चीज तुम्हें समझाता हूँ, बहुत अच्छी चीज तुम्हें समझाने वाला हूँ। मान लो एक ब्लॉक रख दिया, ठीक है, मास एम की, जिसकी रफ्तार कितनी है, v1। देन दिस मास m has velocity v2 after I apply an external force F over a time period of delta t। कुछ टाइम t के लिए मैंने फोर्स लगाया तो रफ्तार क्या चीज में चेंज होगी, v1 से क्या चीज में चेंज हुई। तो बेसिकली तुम कर क्या रहे हो, तुम इस मास पे इसकी जो रफ्तार है उसके ऊपर तुम फोर्स अप्लाई कर रहे हो ना, जो कि डेल्टा टी तक टाइम तक काम कर रहा है। अगर ये फोर्स अप्लाई ही नहीं किया तो इसकी वेलोसिटी चेंज होगी क्या? लेकिन उस टाइम पे ये जो फोर्स जो डेल्टा टी टाइम तक अप्लाई हो रहा है वो किस कंडीशन के ऊपर डिपेंड कर रहा है, इवन इट इज डिपेंड अपॉन माय मास, इजंट इट? एंड दैट इज व्हाई यू आर चेंजिंग द पर्टिकुलर मोमेंट ऑफ द बॉडी और नॉट, and that is why this product is called as momentum. Are you able to get me or not? Mass into velocity is called as momentum. Are you able to understand me perfectly? So that is why basically in physics the motion of a body is represented by two different physical quantities in dynamics, and those motions are, one is called as uh, one is called as momentum, another one is called as kinetic. Okay, are you able to get me or are you able to get me or not? Now you got it. That any kind of dynamics of the body, any kind of dynamics. Dynamics means talking about the velocity of the body. The dynamics means the mass into velocity, mass and velocity both. Got it or not? So these two quantities are talk with respect to two different kind of physical quantities. One is momentum, another one is kinetic energy. Is this clear or not? मेरी बात समझ में आई या नहीं आई? अंडरस्टूड टोटली? ठीक, चलो। तो that's why we bring the Newton's second law. According to first law of motion, that is, if the no external force acts on a moving body, then it moves with a uniform velocity. So if there is no force, mass into velocity will always remain constant or not? Yes, so that means if there is no external force, momentum remains constant. Hence, when the momentum of the body changes, the body must be brought under the net external force, and this is going to be called as Newton's second law. क्या बोलते हैं इसे अपन? Is this clear or not? So what does Newton's second law talks about? Newton's second law only talks about the magnitude of force. First point. ठीक है? It is not talking about even the direction. सिर्फ क्या इसके बारे में बात करता है? मैग्नीट्यूड के बारे में, है ना? न्यूटन्स which says that Newton's second law says that an external force is always required is always required to change the momentum of the body. Are you able to get me or not? So that means we can come to a conclusion of force, that force is nothing but, what is force? I want to change the momentum of the body, so it will be given as change in momentum with respect to dt. Are you able to get me? Not with respect to time. Because I must change. Basically simple, you got it right now only, that when you have any kind of mass m, look over here, when you have any kind of mass m moving from here to there with some velocity v1 with some force, then this is only possible if force is present. Then I got it v2 after traveling for how much time? Delta t. Right or not? So you can say now that initial momentum is mass into velocity v1, isn't it? And then there is a force which is applied for time period t or not, delta t, and that is exactly written as final momentum mass into v2. So what is force then? M v2 minus v1 divided by how much, guys? Delta t. Are you able to get me or not? Understood or not? मजा आया या नहीं मजा आया? इज दिस क्लियर? चलो इतना तो लिख लो, फिर अपन आगे बढ़ते हैं, ठीक है? कुछ डाउट्स वगैरह? ठीक है, ठीक है ना? So I'm not writing this SI unit and all. I'll tell about that in later time. Okay. So let us talk about little bit of SI unit. So as you know, momentum is equal to mass times velocity. So mass is measured in terms of kg, velocity is measured in terms of meter per second. Are you able to get me or not? And force is what? Change in momentum divided by time. You can write m v2 minus v1 divided by, also it is also written as dp by dt. And according to first law of motion, you know that v2 minus v1 is called as what? Acceleration. So force is equal to mass times acceleration. Are you able to get me or not? Is this clear? So now, if I look into the SI unit of acceleration, that is meter per second square. So dimensions of motion are, mass is m, and this is acceleration meter per second square. So ml to the power of minus 2. Are you able to get me or not? And SI unit becomes kg meter per second square, which we also call it as Newton. क्या देते हैं नाम इसका? न्यूटन, 1 न्यूटन, ठीक है? अब ध्यान से देखो तो बेसिकली 1 न्यूटन कैन ऑल्सो बी ब्रॉट इन टर्म्स ऑफ centigrams and all. Yes. So basically kg in terms of centimeters is written as what? In gram it will be 1000 grams. Meter in terms of uh, meter in terms of what we can say in centimeter can be written as 10 to the power of 2 centimeters, and that second remain as it is, that is seconds square. So what is this? 10 to the power of 5. Yes, gram centimeter per second square. And this particular thing, 1 minute, let me erase that thing. And this term is called as dyne. So 1 Newton in terms of SI unit is 10 to the power of 5 dynes. Are you able to get me or not? मेरी बातें समझ में आई? Yes, is this clear? ठीक है, चलो we'll move to the next thing. Now, if we are defining momentum, so we got to know that basically you can write the force as change in momentum divided by time taken, isn't it? So we can say change in momentum is nothing but P final minus P initial divided by time taken. So the question is there that first we should learn how to find this change in momentum or not. Yes. So we will try to find how to find this change in momentum first of all. ठीक है? And then we'll move ahead. ठीक है? Newton's third law will come after too much end. Okay, so don't take tension. We'll see that and then we'll move ahead. ठीक है ना? ठीक. तो देखो अब ध्यान से देखो change in momentum. What is going to be called as change in momentum? Understand this. ठीक है? अब ध्यान से देखो अगर मैं बोलूं P फाइनल माइनस P इनिशियल यही होता है चेंज इन मोमेंटम। अगर मैं बोलूं तुमसे कि एक रोड पे ठीक है एक ब्लॉक रखा हुआ था मास 2 kg का जिसकी रफ्तार थी 3 मीटर पर सेकेंड। हाउ मच वाज द वेलोसिटी? 3 मीटर। This 2 kg in suddenly what happens that uh, I what I did is I with this block 2 kg sudden due to the presence of air dust this 2 kg acquires a air dust of 1 kg. कितना dust acquire कर लेता है? 1 kg and but still it is moving with same velocity which is how much 3 meter per second. So this thing happens within the time interval of let's suppose 10 second. Question is find the force applied by motor applied by motor A, yes, or engine you can say. Find the force applied by engine. क्या क्या? अरे इस ब्लॉक को दौड़ाने के लिए इंजन तो चाहिए ना। एंड फाइंड द चेंज इन मोमेंटम। नो प्रॉब्लम। बताओ क्या होगा? क्या पूछ रहा है? फाइंड द फोर्स अप्लाइड बाय द इंजन एंड फाइंड द चेंज इन मोमेंटम। डू इट। Done. So if I look into the first, I'll find the change in momentum. So basically, this is the initial case, and this is my final case or not. So initially, P initial is what? Mass times velocity. So 2 into 1, 2 into 3, which is how much? 6 kg meter per second. And finally, my momentum, the mass is added 2 plus 1, which is 3 into 3, which is 9 kg per meter per second. Then the force applied, we know that P final minus P initial divided by how much? Time delta t. So P final is 9 minus 6, and in the how much time it happens? 10. So this is 3 by 10, which is 0.3 newtons. Are you able to get me or not? ठीक है, मेरी बात समझ में आई? ठीक, आगे बढ़ूँ मैं? ध्यान से देखो, मान लो एक ब्रिक वॉल है, क्या है? ठीक. And on this brick wall, I project I project one particle. ठीक है, पहले let me draw the diagram. On this brick wall, I project a particle along this particular line. ठीक है, जिसकी मास कितनी है? m, and at that instant of time it has velocity how much? v. कितनी velocity है इसके पास इस टाइम पे? v velocity. The velocity is given. How much is that? v. Okay, and this angle is, let's suppose, theta. Okay, let us consider theta. Okay, the angle made at that time is how much? Theta. This ball rebounds from the wall. Okay, and have mass m itself, and once again the velocity is how much? V itself. With the same velocity it rebounds. Are you able to get me or not? Makes angle once again theta. Question is, find the change in momentum. Find the change in momentum. बताओ. Find the change in find the change. सोचो. क्या होगा? क्या लिखेंगे बताओ? फाइंड द चेंज इन मोमेंटम. ध्यान से देखो. तो कैसे करेंगे? अब एक बात बताओ. तो बेसिकली द net momentum of mv is towards this direction, isn't it? And similarly over here mv is towards this particular direction. Are you able to get me or not? So this mv, basically for this mv, can I just take two components? Isn't it? This, if this angle is theta, this angle will be also how much? Theta. So towards this side mv, you know that if it is a, yeah, like remember that, just for this silly purpose I'm writing, if this is my theta, perpendicular base and hypotenuse, use that term. So if the theta attached is there, बस ऐसे याद रखो, theta attached क्या लिखूंगा? mv cos theta, and theta which is not attached is what? mv sin theta. Simple and logical. Similarly for this mv, once again, how many components? Two components, isn't it? And if this is theta, this angle will be how much? Theta. This is how much? mv cos theta, and this will be how much? mv. Is this perfectly clear? ठीक. अब ध्यान से देखा जाए तो if I know my two components mv cos theta and this mv sin theta and all, so you know that if I want to find the momentum, change in momentum, so look over here. Basically, the initial momentum P initial is written as what? You know that the right hand side is plus I cap, left hand side is minus I cap, top is plus J cap, downward is minus J cap. So initial will be how much? There are two components, MV cos theta and MV sin theta. So MV cos theta I cap minus MV sin theta J cap. This will be my initial momentum or not. Similarly, P final if I want to write. Do you know how to write this now? This will be minus MV cos theta I cap minus MV sin theta J cap. Whenever you get these kind of wall problem, now, it is damn sure you have to resolve the velocity. Okay, without resolving you can't do. Okay, so then I can find the change in momentum, and you know that change in momentum is nothing but P initial, sorry, P final minus, isn't it? What is my P final? Minus MV cos theta I cap minus MV sin theta J cap minus of P initial MV cos theta I cap minus MV sin theta J cap. Are you able to get me or not? So is this term and this term will get cancelled? What I will left with minus 2 MV cos theta I cap, and that is my change in momentum. Are you able to get me or not? Is this clear? Are you able to perfectly understand this? मेरी बात समझ में आई ना? Can I move ahead? ठीक है, चलो अब एक बात एक और क्वेश्चन करो। बोल रहा है कि फ्रॉम अ नोजल, एक मिनट, let me just shift this a little bit. Oh shit, it's just too much big or not. I think this is still visible now. हाँ, बोल रहा है फ्रॉम नोजल ऑफ एरिया ऑफ क्रॉस सेक्शन ए, ठीक है, लिक्विड ऑफ डेंसिटी रो कमिंग आउट विद वेलोसिटी v horizontally and strikes the vertical wall, then इसमें दो क्वेश्चन बनते हैं, मैं दोनों लिख दे रहा हूँ। क्वेश्चन नंबर ए इज then find force applied on wall, ठीक है, एक मिनट, then find force applied on wall if if the water after heating falls down, ठीक है। और सेकंड केस है फाइंड द फोर्स अप्लाइड ऑन द वॉल if the water rebounds with same velocity from wall। बताओ। क्या होगा? बनाओ पहले, उसके आगे बढ़ते हैं। First solve it, then I'll move ahead. बहुत अच्छा क्वेश्चन है ये, बताया तो, इट्स टू मच गुड क्वेश्चन। मैं कुछ हिंट दूं? देखो, दिस इज माय वॉल, this is my particular wall now, and with an nozzle of area of cross section A, ठीक है, इसकी एरिया कितनी दी गई है? A. I fire a water which travels some length over here, isn't it? Consider, and this nozzle is very very nearer over here, okay? And let's suppose this particular length of the water at that instant of time is how much? L. And when it hits, it has velocity how much? V. कितनी है velocity? V. Are you able to get me or not? This is what is condition. Density of the liquid is also given. It is saying that the density of this liquid is how much? Rho. Are you able to get me or not? So in first case, what is happening? The water is spreading on the wall. You can say in simple terms, water spreads on the wall. Can I say like that or not? Again, no. If the water spreads over here, the water spreads on this particular wall, or it falls down, that means that finally my momentum has become zero. Yes, because yes. So the final momentum has become how much? Zero, isn't it? Now, if here velocity is given, then if it is asking about force, then you have to apply only one formula. Just apply P final minus P initial divided by how much, guys? How much time taken? Are you able to get me or not? Is this clear? Now, if I look into the equation, basically P final is how much? Zero. So minus of P initial divided by time taken. This will be my force applied by water on the wall or not? Yes. So force is equal to how much? Minus P initial. And P initial is what? Mass into velocity divided by time taken. Isn't it? Density into volume into velocity divided by how much? Time taken. Now, if you look into the volume, how much volume is applying the force at that instant of time? This much volume of the water which is contained from this area of cross section which travels. So volume is what? Area into length, isn't it? So minus area into length into velocity divided by time taken. But what is length by time? It is that similar velocity or not? So force applied if the water spreads out is how much? Force applied by water is how much? Minus rho a v square, where v is velocity, not volume. Are you able to get me or not? Isn't it? Understood. So force applied by wall will be the positive value of this one, isn't it? So force applied by wall, which is in opposite direction, that is how much? Rho a v square, isn't it? Got it? For the second case, when water rebounds with same velocity, with same velocity, Then once again, force will be equal to P final minus P initial divided by time taken. Yes. So once again, if it rebounds with the same velocity, then the final momentum will be also rho AV square or not. But that will be in opposite direction. So P final will be what? Minus rho AV square minus rho AV square. Sorry, time period will not be there. So what is your answer? Minus 2 rho AV square. So in this case, the force applied by wall is how much? Because it is, if water will rebound, the particular momentum will be in opposite direction or not. So that's why negative minus rho a v square, and p initial is already rho a v square in positive direction. So this one is positive, this one is negative. Are you able to get me? Okay. So force applied by wall in this case is how much? Minus 2 rho a v square. Got it or not? So force of anything is nothing but final momentum minus initial momentum divided by how much? Time taken. Is this clear or not? मेरी बात समझ में आई या नहीं आई? टोटली क्लियर? ठीक है, अब ध्यान से देखो। तो बेसिकली if I look into the force formula, force is dp by dt, isn't it? Now isn't it, this is in the form of, मैंने तुम्हें वो टेक बताई थी ना, you can write if the form is of c is equal to a by b form. किस तरह का फॉर्म हो? c is equal to a by b, and then there is the graph of ab. ओके, मान लो किसी भी तरह का ग्राफ, ऐसे ही ग्राफ हो गया या फिर ऐसे कर्विकल ग्राफ हो, है ना? तो किसी पॉइंट ऑफ टाइम पे, अगर किसी पॉइंट ऑफ टाइम पे उसका तुम स्लोप फाइंड आउट करते हो, क्या फाइंड आउट करते हो? Slope. Slope is, this line will make some angle theta over here or not? So slope over this point is nothing but what? Tan theta. कभी भी slope बनाना है तो क्या करेंगे? कर्व पे पॉइंट सेलेक्ट करेंगे, उसका एक टेंजेंट ड्रॉ करेंगे और फाइंड आउट करेंगे कि वो एक्स एक्सिस के साथ कितना एंगल बना रहा है. आर एबल टू गेट मी और नॉट? And then that slope will be called as tan theta, and this will be the value of c basically at that instant of time, at that instant, isn't it? So if I look into force and momentum and all, basically I can draw a graph of momentum versus time. This is momentum, sorry. This is momentum and this is what? Time. And if I have a graph like this way, momentum continuously increasing with respect to time. If I want to find that how much force is acting at this point P, how much force is working at this point Q. So what I will do, I'll just draw the tangent. I'll do nothing. I'll just draw what? Tangent. For point P, how I'll draw? I'll draw like this. Okay. Right or not? Is this clear or not? Then it will make some angle theta p with the x-axis, and then for q also I can draw like this way. This will be giving me theta q, and always every time how to measure the angle? Take it from positive x-axis and rotate it anti-clockwise. Are you able to get me or not? So then the particular tan theta p will represent the force at p, and tan theta q, force at q will be what? Tan theta q. Are you able to get me on that? Now, which one is bigger, theta q or theta p? Which one will be bigger, theta q or theta p? Theta q is greater than theta p. That means tan theta q will be more than tan theta p. That means force at q is more than force at p. Is this clear or not? मेरी बात समझ में आई या नहीं आई? Are you able to totally get it? ठीक है, ठीक है, चलो आगे बढ़ूँ मैं. यहाँ तक कोई भी दिक्कत नहीं है ना? So these are all the relations of mass, momentum with respect to force and all these kind of things. And then we come to one of the most important conclusion and one of the most important thing, and we define that thing as impulse. सुना है ये वर्ड इम्पल्स? ठीक। अब ध्यान से देखते हैं ये इम्पल्स क्या चीज होता है। तो हम अगर नोटिस करें, अगर हम नोटिस करते हैं, तो इफ आई लुक इनटू द different different kinds of equations or something like that and something like those or something like that. One minute. Why? There is oh, 1 minute. Okay. So let's suppose there is a block, one block, then there is second block which is kept over here. Okay. मान लो इसकी मास, मान लो ये मास सेम मास है एम एम। ठीक है। अच्छा एक काम करते हैं, इसको थोड़ा दूर लेके जाते हैं फिर समझ में आएगा। ठीक है। ध्यान से देखना, मान लो ये मास एम है, इनिशियली इट्स velocity was v1. Now finally its velocity has become how much? v2. But how it will happen if you apply some external force F, isn't it? Now this force will definitely act for some time period. Yes. Now you know that if it acts for some time period, then I know the relation that final momentum minus initial momentum divided by time period is my force, isn't it? So if I can I write the equation that P final means P initial is what? Mass into velocity times V1 plus plus माइनस कैसे? P initial is mass into velocity V1 ना, अभी आराम से देखो। P initial को मैं राइट हैंड साइड में ट्रांसफर कर रहा हूँ, ओके। सो प्लस फोर्स into डेल्टा T and that can be written as mass into V2 or not? तो एक बात ध्यान से देखो, तो ये क्या है? इनिशियल मोमेंटम। ये क्या है? इनिशियल मोमेंटम। और ये क्या है? फाइनल मोमेंटम। तो क्या बोल सकते हो, एक बात बताओ, तुम अगर तुम्हारे पास इनिशियल मोमेंटम कुछ है और फाइनली कुछ हो जा रहा है, तो इसका मतलब बीच में कोई ना कोई तो तुम्हें मोमेंटम को ही ट्रांसफर कर रहा है ना। एक बात बताओ, तुम सोचो, तुम्हारे पास 2 रुपया था, अब 5 रुपया हो गया, तो तुमको कोई रुपया ही देगा तभी तो पैसा बढ़ेगा, या फिर तुमको ऐसे गेहूं दे दिया, चावल दे दिया, उससे पैसा बढ़ जाएगा? ऐसा थोड़ी ना होगा। ऐसा नहीं होगा। अगर तुमको एनर्जी को इंक्रीज करनी है तो तुम क्या प्रोवाइड करोगे? हैं? अगर अगर तुम्हें एनर्जी को इंक्रीज करनी है तो तुम एनर्जी प्रोवाइड करोगे, चाहे कुछ भी हो जाए, किसी भी तरह से, है कि नहीं? तो अगर अगर मेरा मोमेंटम है फाइनल और इनिशियली अगर कुछ मोमेंटम है, तो बेसिकली व्हाट वी आर डूइंग, आर वी प्रोवाइडिंग सम मोमेंटम, एंड this f into t can be told like this is nothing but the momentum imparted or not. Yes, are you able to get me or not? अरे मेरी बात समझ में आ रही है क्या? एंड दिस मोमेंटम इम्पार्टेड, बेटा इसी चीज का नाम होता है इम्पल्स। व्हाट इज इम्पल्स? दिस इज कॉल्ड एज, व्हाई टू गो ऑन फॉर्मूला? तुम तो फॉर्मूला बोल रहे हो, इम्पल्स इज चेंज इन मोमेंटम। व्हाट इज चेंज इन मोमेंटम देन? बट हाउ कम इट इज अपियरिंग? दैट्स व्हाट इज दैट, बिकॉज यू आर डूइंग समथिंग। Yes, just like if you want to change, listen me. Just if you want to change your kinetic energy, what you will do? You will have some final kinetic energy, then you will have some initial kinetic energy, and then you will do some work to change the kinetic energy of the system or not. Yes. To change the kinetic energy, let's suppose if there is final kinetic energy and then there is initial kinetic energy, you need to do some work to change the initial kinetic energy to final kinetic energy. But what is this work done? This is also providing us some energy or not? So definition of work is what? Nothing but the ability to provide energy. That's all. Okay. So what is impulse? Impulse is nothing. Impulse is nothing but the momentum imparted to the body. Im- to the body by a force acting for time period of t, acting on the body for time period t. Are you able to get me or not? मजा आया नहीं मजा आया? ऐसे तुमने कभी पढ़ा है इम्पल्स के बारे में? नहीं ना? तो इम्पल्स कुछ नहीं होता है, अगर ध्यान से देखा जाए तो इम्पल्स इज नथिंग बट इट इज एन मोमेंटम विच इज इटसेल्फ इम्पार्टेड. इम्पल्स बस नया नाम पड़ गया. देखो, मोमेंटम होता है मास इनटू वेलोसिटी. फाइनल फाइनल मोमेंटम भी हो गया क्या? मास इनटू वेलोसिटी. लेकिन ये जो मास इनटू वेलोसिटी है वो प्रेजेंट का है. इसको जब तुम लाना चाहोगे, इफ यू वांट टू ब्रिंग m into v2, you need to apply something, you need to apply the same dimensional quantity, and that same dimensional quantity is brought by force which acts for time period t. Are you able to get me or not? And that is why that force into delta time t is called as impulse. Are you able to get me? मेरी बात समझ में आई या नहीं है? Is this clear? So now, basically, if I look, then a impulse can be having three different kinds of formulas. Okay, how we will see that? Impulse is, once again, it is denoted by J. क्या जैसे denote करते हैं इसे अपन? J से, है ना? So if I look into that, so what I got, that J is nothing but force into delta time period t. Are you able to get me or not? And that is what? Nothing but m v2 minus v1, change in momentum, which is p final minus p initial. Now, as all these things are vector quantity, this j needs to be also my vector quantity. Is this clear? Now, this all happens for which kind of forces? Constant forces and constant velocities and constant velocity. But if the force becomes time dependent, if force becomes time dependent, time dependent in the sense that force is dependent upon time now. Are you able to get me or not? And it is told that find the impulse imparted or momentum imparted between time period t1 and t2. Then what I will have to do? I will have to do the integration from t1 to t2 f of t dt. Are you able to get me or not? Why do we integrate it? You only tell me. Why do we integrate it? Because for every instant of time, I'll have a different force or not. If it is time dependent force, yes. So look over here. See this. If a body, okay, let's understand this in a better way. जैसे एक बॉडी है मास m का, इसके ऊपर मैंने एक फोर्स लगा दिया, टाइम डिपेंडेंट फोर्स है ना, और ये मान लो t इज इक्वल टू 1 सेकेंड पे है और जा कहाँ रहा है, t इज इक्वल टू 2 सेकेंड्स, t इज इक्वल टू 3 सेकेंड्स तक ट्रैवल कर रहा है ना. अब ध्यान से देखो तो इसके हर पॉइंट पे, इवन इफ आई लुक एट every point, all these point when it is going, this force is always variable in nature or not? So the net momentum, net impulse or net momentum which will be imparted will be what? Sum of this force, 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 and it will be very very hard to do all these calculations or not. So the most easiest, most easiest way is integration from t1 to t2 f of dt. Are you able to get me or not? Did you understood it? Clear? So this is something which we wanted to tell. Now, the last important thing, as you know, that here impulse is force into time period or change in momentum. But as I know from trick, if I can write C is equal to A into B, those मतलब अगर जिसको समझ में नहीं आया how I am writing this simple सी form है, just go into means if you want to understand much more in the detail of graphical analysis, I'll share the link of the particular video. There is the two lectures graphical analysis 1, ठीक है, and graphical analysis 2. You can see these two videos now, just you also just complete it, okay, because these two videos are best of graphical analysis. You can get every grasp of graphical analysis. Are you able to get me or not? ठीक है, yeah, I'll share that, okay. Okay, so if we have force versus time period t, and then basically for any, yes, so I can have the force versus time period graph or not. Then look over here, it's like the form of C is equal to A into B. For any kind of C is equal to A into B, the area under the graph AB, area under graph AB or area under FT will provide me the impulse. Are you able to get me or not? Is this perfectly clear? मेरी बात समझ में आ रही है या नहीं आ रही? ठीक है, चलो. तो this was all about related to impulse. There is still much more things. One is called as impulsive force and impulsive tension and all those kind of things. But that we will do uh, in collision. During the time of collision, I'll much more go into the details of this impulsive force and all. Okay. ठीक है. अब ध्यान से सोचना मतलब इसके बाद आता है न्यूटन थर्ड लॉ. इसके बाद तुम्हारे पास आएगा एवरेज फोर्स. अभी दो चीजें बचा हुआ है, एवरेज फोर्स और न्यूटन थर्ड लॉ. सो टुमारो आई विल बी डूइंग एवरेज फोर्स एंड न्यूटन थर्ड लॉ, एंड देन एवरेज ए वी ई आर एज एवरेज फोर्स. Okay, average force and Newton's third law, and then I'll do some numericals. Okay, ठीक है. तो ये पूरा का पूरा पिकअप अपन अब कल करने वाले हैं. आर यू एबल टू गेट मी और नॉट? ठीक है, इज दिस क्लियर? चलो ध्यान से थोड़ा डाउट्स देख लेते हैं. 1 minute, let me message up recording.